So, hello everyone, welcome to GeekNerd. Today we are going to solve the 10th question, shortest unsorted continuous subarray. We have solved the above 9 question and the solution, if you have any doubt in that, then you can see the solution and uh, first I will recommend you to try it by yourself, then see the solution. Okay, and if you want to click the link, then you have to just click the link and hover over there and click it. Okay, but today we are going to solve the shortest unsorted continuous subarray. So let's start. Okay. So it's Leetcode 581 number question. Given an integer array nums, you need to find one continuous subarray such that if you only sort this subarray in non-decreasing order, then the whole array will be sorted in non-decreasing order. It is saying that there is a given nums integer array and we have to find a continuous subarray, and that's the if I sort that continuous subarray, then the whole array will be sorted. Okay, so return the sorted subarray and output its length. Basically it is saying that we have a array and we want that array to be in non-decreasing order. Okay, but that is not in non-decreasing order. That might not be and that might be, but if it is not, then we are going to find a continuous subarray, the minimum length of continuous subarray, and that we will sort it in non-decreasing order. Then the whole array will be in the non-decreasing order. So we have to find the subarray of minimum length and return the length of it. We don't have to change the array that is given to us, but we have to find the length of the minimum length of the sub array, so that we can, if we sort that array, then our whole array will be in the non decreasing order. Okay, let's understand with the example. Here in the first example there is 2, 6, 4, 8, 10, 9, 15. So if you see, then there is after 2, 6 is in non decreasing order, but after 6 there 4 is coming, so it is in the decreasing order. So from 6 to 10, 9, we are, if we sort this, then the whole array will be in the non-decreasing order. Okay, or we can say ascending order. So this is the length of the 6 to 9 is 5, so we are returning 5. Here in the example 2, it is already in the sorted order, so we don't need any array to be sorted. So the length of the sorted order, like sorted array, or like the array that we need to be sorted is 0. So we are returning 0. Here also we have only one element that doesn't need to be sorted, so we are returning 0. Okay. So this is the case, and the length, the constant is 1 to the 10,000. The length vary from the 1 to 10,000, and the element that it contains can be negative 10,000, negative 1 lakh to positive 1 lakh. Okay. So let's start. So what is the brute force approach? What is the brute force? If we think of the brute force approach, then basically what we can do is we'll take every possible subarray and we try to sort it, and if it is if the whole array is sorted, then we are going to return the length, and the length yeah, and we are going to store the minimum length. uh, if you are going to do it, then it will be more complex, as we know, like it will take big of n square. But I don't think like we need that thing, because we have better approach in our mind. But the brute force approach will be like that. We will try every possible subarray, and try to sort it and check whether it is in the sorted order or not. So it will consume more space and more time, and I don't think we should try also. So the second approach, which is little bit optimized, is that what we can do, like optimized one, not very optimized, like partially optimized, partially optimized one, is that what we can do, we can have a different array. Like suppose here we can see that from here 6 2 4 8 10 9 15. After sorting, like let's have this array. Okay, and let's try to sort this. So after sorting, what will be the array will be, what the array will be. Okay, so the 2 will be coming, and then it was 4, then after that 6, then after that 8, then 9, then 10, and then 15. So what we can do, we can have a different array, and that will have the sorted version of the nums, and we will check up to which element, the number are getting different. So if we check the first index, the for the both the array it is 2, but the second index, like the first, like we can say, is a in the 0th index it is same, but in the first index the number is different. So we can have that number, like let I is equal to 1, because it is the first number that we faced different in the sorted and non-sorted order, non-sorted array. And now, and we will have another loop where we will check from the right side onwards. So here the 15, we have both in 15, but now let's have like, what is the index? 0 1 2 3 4 5 6. It's in the sixth index, we have equal number, but in the fifth index we are encountering the different one, so we will make j is equal to 5. Okay, so from one index to fifth index, what are the number? Like 1 2 3 4 5. So basically we are going, the number will be the answer, or we can say the answer will be j minus I plus 1, that is equal to 5. Got it? So the approach will be like that, like will have a different array of this sorted in which is in this sorted order, and and we are going to check the if when from when the number starts to get different. Hmm? And then we'll iterate from the right side onwards also to the last index to the 0th index, and we'll check when we encounter a different element at first, then we'll get out of the loop and we'll have I and j as a 1 and 5, and we'll return the j minus I plus 1. But there might be different, let's take this second example where the array is in the sorted order. Then what we'll do with it? Okay, so here after sorting it also we'll get the same thing, right? So I will go to if we have a loop, then it will first check 0th index, second index, first index, second index, third index. Then it will become 4 and it get out of the loop. So I will be 4 and j will be, like, it will check third index, second index, first index and 0th index, and then it will become -1. So when we get out of the both the loop, and if we find that I is greater than j, then that means the whole array is in ascending order already. So we don't need to, like, sort it. So that means we have to return 0. Means we don't need any array to be sorted, sub-array to be sorted. Okay. um, and we can, for the third example, if we want, then we have, if the n is equal to 1, then if the array length of the array is 1, then we are going to return 0 also. Okay. So let's solve this question. So first I will store n as an nums.length. Okay, and if n equal to 1, then we are going to return 0, because if in array we have only one element that need not to be sorted. Okay. Then we are going to have int I is equal to, you have to check int I is equal to 0. From 0 we are going to start, I think. Okay, no, first we are going to have a sorted nums, right? So int sorted nums is equal to nums dot clone. Okay, so we are first going to clone it, and then we are applying arrays dot sort, and well, sorted nums. That means so in the, okay, it's not an integer, it is a integer array. Okay, so we clone it and we sort, like, we sort the sorted nums. Okay, and now we are going to compare, like, okay, so int I is equal to 0. We'll start from 0. While I is less than n, we have to check whether the I should not be passing the index of the array. So I should be less than n, and nums of I should be equal to nums of, not nums of, sorted nums of I. Okay, and if it satisfies, then we are going to increment the I. Nice, I think it is good. Then let have int j is equal to n minus 1, and we have to check whether the j, as we are decreasing the j, so it should be greater than equal to 0. So j should be greater than equal to 0, and the case should be like that, the nums j is equal to sorted nums j. Okay, and j should be decreased. So as we have discussed, if we find I is I is greater than j, then we are going to return 0. So we can do like that. We can use a ternary operator also. So return if I greater than j, then we are going to return 0. Otherwise j minus I plus 1. Okay. J minus, returning j minus I plus 1. Okay, nice. I think it will pass. Okay, let's submit it. Okay, it is passing, but the time complexity of this algorithm is big O of n log n. Why is it? Because we use sorted. We are sorting the nums and storing it in a different array. So here the time complexity is n log n because the sorting takes n log n time complexity. So and the space complexity is of big O of n because we are taking additional array for to solve this question. So isn't there any better approach than this? Yes, there is. So let's discuss about the optimized approach. Okay. So optimized approach. Very optimized approach. It is the best approach for this question. So we have to think like that. Let's pause the video for a while and think. Like, are you able to think about any optimized approach? Try to think, because we want a array in ascending order, right? Or we can say increasing order. So what are the criterias to be in that? It's the hint. Pause video for some while and think about it. If you get it, then try to do it yourself. Otherwise, I will explain it to you. Okay. So let's continue. So here we can see that the 2, 6, 4, 8, 10, 9 and 15 is there. Okay. If I can say, if I can, am I correct if I say that 15 will be in the correct position if the 15 is the largest among all the number? Am I correct to say that? What do you think? Right? If 9 would be in the correct position if only the maximum number among all that are there in the left side is there. Are you getting it? What I'm saying? Let me copy it. Okay. We said that after sorting it, let's have this sorted one also. It is this sorted one. Okay. So 15 is in the correct position, right? So why is it in the correct position? Because every element that are there in the left side of it are smaller than this. So the if we consider this like the maximum of all these elements, then we are getting 15. But if we consider this and find the maximum among this subarray, is it 9? No, it is not, right? If it is 10, then it is in the correct position, right? If I change the question like this, 9, 10, then the maximum number that is there in in this subarray will be 10, and 10 is in the correct position, right? As it is here. Here in the 9 is also in the correct position, right? The 8 is in also correct position. Then only because 9, why is 9 is in the current position? Because the maximum of it is 9. Here in the maximum of these 4 element is 8. But if we consider this subarray, then the maximum is 4. So we can say that like this is the last. If we consider a array, then that will be the last element of the subarray, right? But the question was like this. So first we have encountered this. So this will be the last element. So in algorithm, what we are going to do, we are going to check from this one like this, because starting from the 0 index. Why is that? Because we are checking the maximum. So what we are going to do, we are going to have a int max. Let's have max in element, and we are going to initialize it as a nums 0, and we are going to iterate from the first index. Okay. So then what we are going to do is we are going to assign the max scene is equal to math.max of max scene, comma numpsci. Okay, so if it is a first index, then the maximum will be 2 comma 6. 2 comma 6 will be, the maximum will be 6, the maximum scene is 6. And is it the num I? Yes, it is. Huh? So we'll proceed forward. Okay, here 4, and here we'll check like till this element, what is the maximum? 6 is it? The 6. So is 6 is there in the last position? No, it is not. So the last element of the sorted continuous array will be this one. Okay, and if we get any changes in the like forward, then we are going to then we are going to update the last index of it. Are you getting it what I'm saying? Okay. Huh. It's like that. We'll find the same thing for the first index of the continuous array. How will we do that? We are going to do the vice versa. Like we are going to have the int min sin, and we are going to assign it as a nums n minus 1. So the if I want to like explain you, let's think about like this. uh, when the 2 is in the correct position, if if the element of the nums, the minimum of the element that are there in the nums is 2, and we have 2 here, then it is in the correct position, right? So it's good, right? But if we choose this, huh, then what is the minimum of this subarray? The minimum of this subarray is 4, huh? But is it there in the first element in the subarray? No, it is not. So we are going to have the first element of the subarray, or is the index 1. So here will get the initial index of the subarray as 1, because we didn't get the minimum of the subarray as in the first index of it, because the minimum of the subarray will be 4, and we have 6 in the first index of the subarray. In case of the last index, we get if we consider this subarray, and the maximum of this subarray is 10, but we didn't find anything, we didn't find the maximum element in the last element of the subarray. So the j will be the index of the 9, like 0 1 2 3 4 5. So 5, and in the end we are going to return j minus I plus 1. Okay, but for the sorted case, the same like what will happen if in case of the sorted array? Let me think what we can do. Because we are proceeding forward, right? What we can do is now, we initialize the I and j, or we can name it as a start and end, because we are iterating with the I and j. So start and end. So end minus start minus 1, and we'll have it as a start is equal to minus 1. Okay, and is equal to -1, and if we check if it is if the start and end element is -1, then we are going to return 0. Or we can, what we can do is, as start minus end plus 1, we are calculating it, so we can make end as a -2. So if we didn't encounter anything and we are not changing the start and end, then it will be gradually 0. Okay, so we can do that also. So let me delete it from this to this. For the single element, we are returning 0 only. Okay, so like it in start is equal to -1 and is equal to -2. Okay, we are doing that, and mean seen is equal to, like, we are checking the mean from last index, right? So uh, nums minus n minus 1. Okay, and max seen is equal to nums 0. Okay, and we are going to iterate over the array. So while no, let's use for loop, int I is equal to 0, I less, not 0, 1, because we have initialized as maxin as an index 1, so we are checking from the index, like we have initialized maxin as the element of first 0th index element of the nums, so we are checking from the first index onwards. So I should be less than nums dot length, or n I plus plus. Okay. hmm. What we are going to do, we are like we are changing the mean maxin as a math dot max as max of maxin, comma nums I. Okay, so here like what we are doing here is we are checking like this, like this. Okay, if we are like here, like we are calculating that initially we have maxin as a max. Okay, initially we have maxin as num 0. Okay, so we are adding this also in the subarray, so we are calculating the max. We are calculating, we are like evaluating if the current element is maximum than the maxin. If it is, then we are updating the maxin. So we are like calculating the max of this subarray, and if it is in the current with the current element, then we'll proceed further. If it is not in the current, if like suppose we are in this state, then the current the maxin is 6, also 6 only, but the current element is different from the maxin, so we are going to change that, right? We are going to add a end element, because we are starting from the beginning, because we want end index of the continuous subarray that we need to be sorted. Okay, so we are going to, if maxin is not equal to nums I, if it is not equal to that, then we are going to change the and as I. Okay. Hmm? And we are going to proceed further, and at the end we are going to find a particular end index of the continuous subarray. Okay, like that only we are going to do with j. So like let's have a I only, and we are starting from the last index. Okay, and I should be greater than equal to 0, and I plus plus, and here we are doing the vice versa. M seen, okay, not plus plus, minus minus will be there. Okay, min seen, and math dot min will be there, min seen comma nums I. Okay, okay, it's not from -1, -2 because -1 is already there, right? So what we are doing is calculating the first index. So suppose we are like here in the 15, and 9, huh? So if you check the 15 and 9, and what is the minimum of it? 9 is there, and here it is 9. So for the first index, it is if this would be the subarray, then we will not have any issue with it. But if you proceed to this one, and the minimum is 9, but we have 10, so I will mark it as the first index of the subarray. Like that, we'll reach to this also, and the minimum of it will be 4, but the current element is 6, so we are updating the start element at this. But when we calculate this, the start minimum of it, minimum of this array is 2, but the starting element is also 2, so we are not updating start, and the start will be in this index, and the end will be in this index, so we will consider this array. Are you understanding it? So if mean seen is not equal to nums I, then basically we are going to do the start index as I. Okay, and in the end we are going to return end minus start plus 1. Sorry, plus 1 plus 1. Okay, I think it is done. Let's run it. Sorry. Okay, the normal custom test gets passed, so let's submit it. It is passed, and the time complexity of it is big O of n, and the space complexity of it is big O of 1. So it is the optimized approach. So I hope you have understood the solution. If you have any doubt, then you can comment down below. I will help you to clear it out. And if you like the video, then like it, and if you have any feedback on this, then comment down below. The comment is open for you. And if you want to see this kind of video in future, so please consider to subscribe it, because it will motivate me and to make video in future. So thank you, and have a nice day. Till we'll meet you in the next video. Till then, bye.